Okay, this is exponential growth or decay. Am I looking at a growth model or a decay model? Here's the standard. I'm not going to waste much time on the video for that. All right, you have two equations for an exponential function. You've got, and as a matter of fact, even this one can be written just like this. But you've got this one where we have y equals a times b to the x, or we have y equals a, they both have a, and b is either 1 plus r or 1 minus r. If it's growth, you're going to add. If it's decay, you're going to subtract. And both of them, and this one just says t, which is time. Usually your exponent is time, whether it's x or something else. All right, so a is always the initial amount, is what you start out with. Whatever you're looking at, it's this number you start out with. Now b, this is how you tell whether or not you're using r or using b for the most part. If you use b if they have words like half, double, triple, fourth, quadruple, those kinds of things. So if they say those kinds of words, you're using b. Now, I said etc. because I just can't name them all that they might use. There's a bunch they might use. When you see a percent sign, that's when you use rate. That's when you use this one with the R. Now, X or T, which is time, is going to be months, years, hours, minutes, etc. So you just have to pay attention to what they're telling you. All right, if my function is growth, my b, which is this part, will be greater than 1. So if I have this, and I can't say if it's a fraction that it's less than 1, because this can be written as 5/2. So don't think that. So if it's greater than 1, this right here, this is growth. You see how this one is less than 1, it's 0.75, that's decay. So greater than 1, growth, less than 1, decay. All right, here's a growth model. A growth model will start from the left and go up. That's growth. A decay model will start, and I just drew more than one. A decay model will start on the left and swoop down like this. So it's up high on the left, that's decay. All right, if I'm given this equation right here, I need to first decide, is this growth or is it decay? This number's less than 1, so it is decay. Now, what is my decay factor? My decay factor is this number right here, which is 0.25. However, that is not my rate. My rate is 1 minus r. Remember in the formula, you had 1 plus or minus r. Okay, so this is my decay factor. So if I do 1 minus 0.25, I get 0.75. Okay, that's actually better than putting that. I don't know why I didn't do that to begin with. So that is my rate of decay. My initial amount is 23. We're just learning what things are right now. All right. This one has no number. If you notice, okay, it's just written like this, which is confusing. It always confuses y'all because there's more than one number with growth or with exponential. The number here is the factor. It is the base. This is your initial starting point. This one here doesn't have parentheses. That's because your initial starting point is 1, and we don't ever write ones. So 1.5 is either growth or decay, and since it's greater than 1, it's your growth factor. Now, I have a growth factor of 1.5. How did I get there? Well, you remember the formula. It's 1 plus r or 1 minus r. So 1 plus some number gave me 1.5. So to get to 1.5, 1 plus 0.5 is 1.5. So that is my rate of growth. So my rate of growth is 0.5 and my initial value is 1. Again, that is understood to be there. All right, this one, 1.07, that's bigger than 1, it's growth. And this is my growth factor. 1.07. My rate of growth is 0.07 or 7%. Again, 1 plus something is 1.07. You can think of it as you just subtract 1 and you'll get it. So it's 7%. So what is my initial value? 1.4. Okay. Is this function exponential? You have to look and see what you're doing. You're multiplying by a third or dividing by 3. Now, when we write our function, we write it as what are we multiplying by to get there. So, 20, and you can do it this way. You can do 27, this number, divided by 81 in your calculator. It'll give you 1/3. So, that's how you find that. This is decay because it's going down. You know, you wouldn't see this on your notes initially, but it's going down, so it's obviously decay. So it's a factor of 1/3, and my initial value, the 0 value, is 81. So 81 times 1/3 to the x power. Same thing on this one. I need my 0 value. I am multiplying by 2.2. How do you find it? Look, I couldn't do this in my head. You would do 29.04 and you would divide it by the term above it. Now, you would want to make sure they all have the same thing. You would want to do a few to be sure that this is indeed an exponential function. So it is exponential, and you take 2904 and divide it by 13.2 and you get 2.5. So that's what you're multiplying by all the way down. My initial value, that's where x is 0. So if I'm multiplying by 2.2 to get here, I would take 13.2 and divide it by 2.2 to reach the 6. But anyway, so that's my initial thing. So 6 times 2.2 to the x power. Okay, thank you. What happened here?